Millions of years ago, the world was said to exist in not 7 continents, but a single supercontinent, titled Pangaea. This supercontinent slowly floated apart due to a process called Continental Drift, or the idea that continents are moving around on Earth's surface. This massive supercontinent broke into several pieces, northern pieces labeled Laurasia, and southern pieces labeled Gondwanaland, before gliding apart. North America drifting northwest, South America drifting southwest, Africa drifting northeast, India drifting northeast, Eurasia drifting northeast, Australia drifting southeast, and Antarctica drifting southeast. Originally proposed by German polar researcher, geophysicist, and meteorologist Alfred Lothar Wegener, the continental drift theory has eventually been widely accepted throughout the world. Wegener came up with his idea when he was looking at a map and saw that the continents seemed to fit together like puzzle pieces, so he decided to peer closer into the thought that they were once all together.
3 types of evidence supported Wegener's revolutionized theory. Matching fossil, glacier, and rock type was found on matching sides of the continents. Matching fossil evidence of Mesosaurus, a freshwater reptile similar to a small crocodile, was found in South America and Africa. Matching fossil evidence of Glossoptens, an ancient fern, was found in Africa, South America, India, Australia, and Antarctica. Matching fossil evidence of Lystrosaurus, a land reptile, was found in India, Africa, and Antarctica. And matching fossil evidence of Cynonathus, a mammal-like reptile, a sort of mix between a tiger and a crocodile, was found in Africa and South America. Glacial evidence was found in South America, Africa, India, and Australia, as glacial sediment that once covered Gondwanaland was found in all of those places. Rock-type evidence was found through similar rock formations throughout the world on different continents, proving that they must have been together at some point.
More evidence toward the continental drift theory is the process of seafloor spreading at the mid-ocean ranges, which are basically underwater mountain ranges with deep trenches and rift valleys. Seafloor spreading is where the magma from the mantle of the Earth forces up through the crust and forms new ocean floor, which then forces the mid-ocean ranges further apart. This procedure is occurring all the time and is proven by 2 types of evidence, rock types and magnetism. Scientists studied rocks on both sides of the magma-created crust and noted that the patterns were the same on each side, which means that they were created at the same point in time and forced equally apart.
The top 2 layers of Earth are separated into different sections that move, called plates. Earth's plate tectonics include the lithosphere, which is the crust and upper mantle about 100 kilometers thick, and the asthenosphere, lower mantle about 700 kilometers thick. It is also semi-solid. The lithospheric plates move around on top of the asthenosphere by way of convection. The outer core gives off heat, which rises to the top of the mantle, which causes seafloor spreading, which creates new crust that then cools and goes back, which begins the cycle all over again. Because they are able to move, the lithospheric plates keep the ocean floor from getting ultimately bigger from seafloor spreading at subduction zones. Subduction zones are where the more dense lithospheric plates slide underneath the less dense lithospheric plates, making the ocean floor smaller. Paired up with seafloor spreading, the ocean stays at a constant size. Plate boundaries are the points at which 2 plates meet and create, destroy, or conserve crust. The first of 3 types of plate boundaries is divergent boundaries. At divergent boundaries, the plates are moving away from one another, therefore creating crust through the seafloor spreading that goes on between the 2 plates. Examples of divergent boundaries include mid-Atlantic ridges, Iceland, the Red Sea, Lake Baikal, Gakkel Ridge, and Galapagos Rise.
The second type of plate boundaries is convergent boundaries. At convergent boundaries, the plates are moving toward each other, destroying crust. Convergent boundaries are divided into 3 subdivisions: oceanic-continental, oceanic-oceanic, and continental-continental, all of which abolish crust in a different way. At oceanic continental convergent boundaries, crust is demolished through a form of subduction where the less dense oceanic crust sinks underneath the more dense continental crust. Examples of these boundaries are the Andes Mountains and Mount St. Helens. At oceanic convergent boundaries, crust is demolished through a form of subduction where the oldest crust subducts under the youngest crust, producing volcanic island change such as the Philippines and Japan. At continental convergent boundaries, crust is demolished and mountains are created as the crust of each plate is shoved up against each. Examples of these boundaries are the Himalayas, the Appalachians, the Rockies, and the Alps.
The third type of plate boundaries is transform boundaries. At transform boundaries, the plates move past each other, causing pressure and friction to build up, resulting in earthquakes that conserve the crust. An example of these boundaries is the San Andreas Fault located on the Pacific coast of the U.S.